So, Tariq, can you brief about yourself?
Yeah, hi Ganesh. Can you hear me?
Yes.
Okay. I have experience around 5 years of experience in data engineering domain. Worked on open source technologies and cloud also. And I have used data browser solutions, Databricks, and Snowflake. I wanted to get a good exposure in terms of projects, real-time projects, where I'm dealing with a negotiator to express uh, the knowledge to get more clarity in terms of interviews.
Got it. And Arsh?
Hello.
Yes. Can you? Yeah. Can you hear us?
Yeah.
Yeah. Can you brief about yourself?
So I work as a business transformation executive at HCL Technologies, and I've been working for 2 years over there. So lately, I wanted to learn more about the Python and this field, AWS and data engineering field. So I intend to join the course.
Okay. And I can say one more, Anand Ratnakumar.
Hello.
Yeah. Can you brief about yourself, Ratnakumar?
Yeah, myself, I'm Ratan Kumar. I completed my MBA in 2022. Currently, I was working as an HR executive. I was 1 year of experience. I was much more interested in data domain, so I want to join data engineering.
Okay. Thank you. Thank you. Thanks for your time. And
Yes.
Aditya, you can go ahead.
Sure. Thank you so much. Thank you so much for joining. My name is Aditya. I am currently working as a senior data engineer and ML engineer in one of the Fortune 100 organization. I have experience near about 8 years totally into the data domain, starting from on-premise ETL solution, say Informatica, Alteryx, and then I gradually moved to the cloud side of things, where I have worked predominantly on AWS, which is Amazon Web Services, and Azure, which is provided by Microsoft. Then I had exposure to ML engineering as well, wherein I am building and maintaining and executed data science models. So currently my role requires me to build data engineering pipeline and side by side execute the data science model that are being built by data scientist. So that's a brief about me. I'll welcome you all to the first demo session of this data engineering course, right? So let's get into it, right? Let me share my screen. Okay, I'm sharing my screen. Just let me know if it's visible to you.
We can see.
Awesome, thank you. So this course is basically dedicated on data engineering. And for doing the data engineering, we will be utilizing AWS as our cloud tech stack, and we will be utilizing predominantly Databricks for building our ETL pipeline. So before we deep dive into our course and all, right? First of all, let's try to understand what exactly AWS data engineering is, or what exactly data engineering is all about, right? So let's try to learn this from a very basic fundamental story. So the story says like this: back in 2012, the amount of data that a normal person is generating on this planet, right? Let's suppose that amount of data is X GB. Imagine in a whole day. Same person today, right? After 10, 11 odd years, generating the same amount of data in less than 1 hour, right? So what exactly happened? The data generated by a single person has increased approximately 20 times within a span of last 10 odd years. That is with respect to a normal user. When we talk about the organizations, when we talk about the different applications, the amount of data that they are producing is increasing humongously. It's keep on going and going and going, right? And nowadays, right, everyone says data is the new gold. Why? Because with the help of data, we can generate lot many insights, right? I'll give you one example of how data help us generating more insight. Let's say there is a food company who has outlets in different part of our country. Let's say in each city, this food company has its outlets. So they are introducing a new product as part of their shops, right? So let's say they have 400 outlets and they are introducing a new product in each of their outlet, right? So how exactly things happens in a normal day in any food outlet is there are customer who comes to the food outlet. They see the different variety of items available in the option menu for that cart or for that shop. Accordingly, they will, you know, purchase some item or they will place an order. Depending upon the order they have placed, a order invoice has been generated, which will, contain the order details, the details of the person who has ordered this amount, and what is the total amount value for that order, and so on, right? And this keep on happening throughout the day. Imagine a store which expect near about 100 odd orders in a day. They would produce 100 odd invoices, right? So invoices is nothing but simple bills. Imagine this is happening across the whole country. We have 400 outlets, 400 outlets into 100 orders per day, right? So we have near about how many? So we have near about 40,000 different orders coming in a day, right? So imagine this is happening 24 cross 7, 365 days in a year. So down the line, after 1 year, I have a big amount of order data available in my database. Okay. So now as a business user, I want to understand what is my best selling product, what is my less selling product or worst selling product, which product goes together, how would I be doing that, right? How would I be answering this question? So to answer this question, we need the data of the orders that has been placed throughout the 1 year, right? So using that data, I can quickly find out which order or which item has been the most sell item and which item is the least sell item. Accordingly, next year, I'll take a decision whether to continue the item which is the least sold from my menu because it is not producing me any benefit, right? Similarly, if a company is introducing a new product in their line, right? So they can understand throughout the 1 year period how their product is performing and whether they want to continue this product down the line or whether they want to discontinue it. How exactly they see all of this information? So basically there is raw information flowing in from each of the different outlets of the company into the company database. There are some folks like us data engineers who understand this data, converts this raw data into meaningful insights, and then answer the question. What question they answer? What is the best selling product? What is the least selling product? What is the average ticket size? Which two products goes hand in hand, and so on, right? So they basically enables a dashboard or a report which quickly tells the business users this is what exactly happened throughout the year, or say last 5 years, 10 years, and so on, right? So that what exactly is the power of data. This is one small simple example with which we can understand that what is the power of data and what business driven decisions we can take with the help of data itself, right? So that what exactly is the basic use of data, or that is the importance of data going forward. Right. Now let me quickly talk about what exactly data engineering is, right? So we have understood from a basic example that data is of utmost importance to us. With the help of data, we can generate lot many insights, and this can enable our business to take more informed decisions. And this will enable the business to generate more revenue, right? So I think you all will agree to that point. The amount of data that is being generated today is going to increase in next year and next year and then year post that, right? So the amount of data is going to increase year on year, right? And how exactly organization manage this data, right? Or basically in organization, who manages this large scale of data? It's the responsibility of data engineers to manage the large scale data which is coming in, right? And build, manage, store, process, transform, and generate insights out of it by building data engineering pipelines, right? So that exactly data engineering is all about in a nutshell, right? It's about managing the data, building the infrastructure that is capable enough to handle the large scale of data coming in, right? If let's say the data size is small, I have 1,000, 2,000 rows, I can quickly do all the data analysis using an Excel sheet, MS Excel sheet, right? And it is 100% doable. You can do everything with Excel sheet. It's a very powerful tool. But as soon as the size of the data is keep on increasing, Excel cannot any longer handle it, right? So how exactly you can process a data? So you need powerful solutions. You need powerful infrastructure. Who provides that infrastructure? This infrastructure can be provided by various cloud providers. And who build the infrastructure? It's the responsibility of data engineer who build the infrastructure on which the analysis of the data can be performed, or basically we can store our data and process our data, right? So what from this example, what we have understood, what are the basic responsibilities of data engineer? So the basic responsibility is collecting the raw information, the raw data coming from various sources. In our previous example, the order data coming from the food stores, right? Transform it. So basically the raw information is coming in. We want to answer some question like what is the best selling product? So we need to transform it, build pipelines, and store it somewhere, the final result, right? Maybe in the form of dashboard or maybe in the form of reports, right? And what is the importance of data engineering in whole this exercise? It help us take more informed decisions, right? How? Because if I want to introduce a new product next year, I can understand from my past history how my business is performing, which product is selling well, which product is not selling well, what discounts I need to give, what discount I need to remove, correct? So what are the challenges of data engineers in today's world? It's how they are going to handle the large scale data, basically scalability of the data. The second biggest challenge of a data engineer is governance. What exactly is governance is, right? So since we are producing large amount of data, we also need to secure it, meaning no unintended person should be having access to my data, correct? For example, I am having my company profit, company financial information. I don't want this data to become public so that other can get benefit out of it. So how exactly I'll manage and maintain security? That is the challenge for data engineering that we take with both hands. Now, what other challenges today's world poses? So we have to handle real time streaming data as well, because nowadays the speed of the data is very fast, right? We deal everything in real time, starting with lots of social media platforms, we have UPI, we have online transaction happening, everything happens in real time. And we as a data engineer need to handle this real time processing, right? Then how exactly we do data modeling, how exactly we build automations and so on. So these are the basic uh, challenges or the uses of what data engineers do in their day-to-day life, right? Now we have established the fact that what exactly data engineering is and what in a day-to-day life data engineer do, right? Let's quickly move on to our, main important topic, cloud. right? So what exactly cloud is? Cloud is a new topic these days. So what exactly cloud means to us, what it brings to us, right? So the picture that you are seeing in this red cross icon, it's not the cloud that we are going to talk about in our future lectures, right? So cloud is the picture that is with this green uh, outline, right? So it's nothing but a bunch of different computer or servers that are placed securely in a highly secure building and environment where we can keep our data safe and secure, right? Again, I'll repeat, the cloud that we are going to learn is nothing but a place where there are a lot of machines are placed. You can call them as servers. These machines are highly safe and they are well away from the reach of us users, right? The engineers of that cloud can interact with these machines, but we as a user of these cloud cannot interact directly with the machines, meaning we cannot touch them directly. They are far away from our reach, right? So what a basic example of cloud that we are using day in, day out in our life. Everyone, I believe, are or maybe used Google Drive in their life, or maybe if they are Apple users, they have used iDrive, right? Sorry, iCloud. So, what exactly Google Drive or iCloud is, right? So, these are an examples of cloud providers where you can securely keep your data, right, well away from your reach. And whenever you want to access it, you can access it. How? With the help of internet, right? When you place, let's say, a file in Google Drive, now you can access this file from anywhere in the world with the help of a laptop, with the help of a mobile or a computer. The only thing that you need is the user ID and password, right? And you can access it over the internet without any issue, right? So that is the very basic example of cloud that we have used in our day-to-day life. Um, and now in terms of data engineering, there are various cloud providers that provide this kind of service to us. The picture on the right hand side depicts about this, right? So we have mainly predominantly AWS, Azure, Google Cloud, IBM, Salesforce, Oracle. These are the major cloud providers that provides this kind of service where we can securely keep our data safe. However, if we just look at the market numbers, right, and these numbers are published by Statista. This report came in Q1 2023, right? And I'm not seeing this report changing any far again in the new year as well. AWS is leading industry in the cloud provider space. You can see this. It's winning by a good amount of margin, followed by Azure, followed by Google, and there are a lot of bunch of clouds that altogether contributes to 10% of this domain, right? And hence, this course is built on AWS cloud, right? Because AWS cloud is one of the highly demanded skill or niche which is being in demand in the market, and there are a good number of openings for AWS cloud provider or AWS data engineering, right? However, I'm not denying that Azure is not important. Azure is also important, but since AWS has a better market share, so the chance of getting a posting for AWS is higher compared to Azure, right? And I'm seeing this number will be growing in future as well. Okay, so that is a very basic, intro of what exactly cloud is. Now we'll understand what exactly AWS cloud computing is, right? So far we just understood what exactly cloud means. Now what exactly AWS cloud computing emphasizes, right? So imagine AWS cloud computer is a big room fill up of multiple servers. The picture that we have just seen in our previous slide, right? Imagine AWS cloud is a big room fill up of various computers working together that are far away from our reach, and we can access the information stored in those computer with the help of our internet. I'll give you one quick example. So we have our laptops or our phones or our personal computers, right? So in each of these, there is one thing in common, which is called storage or memory, correct? So every computer, phone has different configuration, and accordingly, they have different memory, right? So if you want to save some information in your computer, you have to save that information in your C drive, D drive, or in case of phones, it is the normal storage, right? And how much you can store, it depends upon how much memory you have in your computer or in your phone. If let's say you ran out of memory in your phone and you want to save more information, what you will have to do, right? Either you have to delete the existing set of files from your mobile phone, or either you have to compress your file down so that they take less space and you have some more space available where you can safely secure your files, correct? This you can do with your personal computer, with your mobile phone. However, let's imagine that scenario that all the information available in your computer or your mobile phone is of high importance. You cannot either delete, either you cannot compress it. So what other options that you can have at your hand? The only option at your hand is to increase your storage, right? In computers, it is possible by adding external drives. However, in case of mobile phone, it is not easily possible, right? Because these days, mobile phones doesn't come with micro SSD cards as an option, so you cannot extend it. So how do we increase the space? We put all the information in the cloud through our mobile phone, again in Google Drive, and then we can delete some information from our phone so that our phone's space will increase. Same thing happens in case of big organization, right? So big organization produces large amount of data and they need space to store that large amount of data. And how exactly they can store it safely? They can store these information back in AWS cloud, right? Or in any cloud so that they can access the information without any worry about how exactly I am going to increase the space at my end, right? So that is basically about AWS cloud computing or anything about cloud computing, right? It offers services like storing data, running programs, and doing smart things with data, right? Instead of buying our own set of storage or own set of computers, we can rent the services from AWS whenever we need them, right? I'll give you one example of this. So let's imagine you are planning to go on a trip and you want to see or visit a couple of countries over there. So you want to travel the countries, and for traveling you decided to travel by road, and by road so you need a car, right? So there are two options. One option is you go in that country, you buy a car over there, right? And you will be living only for 10-15 odd days. You buy the car, you buy the insurance, right? You have taken the license and everything. Then you have, paid a good amount of money because the car is expensive for sure. And then you have used the car for 10 days and now you cannot, take the car back with you at your own country, right? So the only option is to, let the car over there as it is. Either you can resell or let the car over there only. And even in case of resale, you are getting very small portion back. The second option is you go over there, you rent a car, right? You don't need to worry about the insurance, you need not to worry about the license, you need not to worry about any other cost. The only thing you need to worry about is the money you have to pay depending upon how many days or how many kilometers you are riding the car, right? So you are going there for only 10 days. So guys, tell me which options do you see is good options for a traveler who is going to a different country? Option one, buying a new car over there, or option two, renting a new car over there?
When you were talking about this,
Correct. Absolutely right. And it makes sense because we need not to worry about anything, right? Who will manage the license, who will take the registration and all. Same thing happens in case of cloud computing, right? So these days, organization have to run a lot of analytics, lot of programs, or they want to store a lot of highly important data or highly fast moving data, right? Let's take an example again. So there is an organization who wants to run the analysis on the data. And for running the large amount of analysis, they need high server, which has say 1 terabyte of RAM and memory, right? So you know how expensive buying RAM is. If you go buy 16 GB RAM computer itself, it is going to cost more. And as soon as you increase the RAM from 16 GB to 32 GB, the cost of the computer will go on crazy. Now I am talking about not 16 GB, not 32 GB. I'm just talking about 500 GB or 1 terabyte of compute power, right? Imagine how much money the organization have to pay just to take this kind of server so that they can run their analysis, right? So what option they have? They can buy the whole server, then manage the server, right? Managing the server itself is a lot of task for them. They need to employ 4 5 workers just to manage the server. Now, server generally heats quickly because they are, machines, right? And machines keep on heating. So you need a cooling system for them, right? And you need lot of different infrastructure just to maintain and run the server. And the funny part is you just need to run the server for 2 or 3 months because your analysis is done within 3 months, and you no longer anymore now need this server for next 5 6 months or say 1 year, right? So unnecessary, what we are going to do, we are going to buy the server, we are going to pay heavy price for it, we are going to create a new team who is going to manage the server, we need the cooling system for that server, we need space and so on, lot of headaches. On the contrary, we have AWS as cloud provider who is saying, I have huge capacity of servers with me, guys, come take as many servers as you need, right? You need 1 terabyte, I'll give you 2 terabyte. Come to me, right? And what I need is just give me the price of how much or how many hours you are using my server. For example, you are using this server for 28 days. So only pay me for 28 days the rent. I am not going to charge you anything. I am not going to take you any money for cooling. I'm not going to take you any money for, say, the team, right, who is managing the server. I'm just taking money for how many hours you are using my server. That's it. You just have to pay for it, right? It's a good option for the organization, right? They are they are running their analysis for 28 days, 20 days, whatever it is, and they are just paying for that money. They don't have any headache for maintaining the servers and all, right? So that's what exactly AWS cloud computing gives back to organization, the liberty to run heavy, huge scale analysis, store data without a worry about managing, buying, selling all of these servers, right? So that's what quick thing about AWS cloud computing, right? It enables us to run quick analysis within couple of seconds without a need of worrying about any infrastructure as we go along, right? Now, this is all about AWS cloud computing. Let's quickly talk about the topics that we are going to cover in our sessions going forward, right? So we will talk about basics of SQLs and Python, right? Then we will talk about Spark, introduction of Spark and Hadoop. Then we are going to talk about PySpark, the practical side of PySpark, right? How do we handle data PySpark? And for doing everything, we are going to use Databricks and AWS, right? Then we are going to talk about the various common services of AWS, which are S3, Lambda, Kinesis, Glue, Athena, EMR, um, CloudWatch, IAM, EC2, right? Not only that, all of these services are highly practical oriented, meaning there is no theory as such in each of these services within our course curriculum. The way we have designed our curriculum is to give you the practical side of things because we know you all are working professionals, and as soon as you learn these services you may have to implement these services in your day-to-day work. So we are going to give the learnings in a way that you can implement this service within your work in no time, right? So we will give you hands-on expertise in these services since day one. Moreover, we will give you the industry standards of how these services are being used in any organization day in, day out, right? So that you won't feel left out, you won't feel, how exactly I should be using. I know the theory, but I don't know how to use it. So this problem will also be solved. Moreover, we will give you the additional interview questions that may come up on each of these services, right? Depending upon the past experience we have from talking to a lot many candidates, from giving through a lot of interviews, right? So these are the services that we are going to discuss in our program going forward. Not only that, once we are done with our services, we will talk about the AWS use cases and case studies that AWS provides on their website. We were going to talk about the industry standard case studies and different projects of data engineering that you can build, use, and implement in their day-to-day life, right? This will help you, you know, talk about the projects in your resume with more confidence. Okay. Any questions so far? Yes, no, maybe. Okay, I'll take this as a no, right? So I'm done with my presentation that I have with me so far, right? I'll probably give you a glimpse of the power of AWS data engineering, how easy is to set up basic data processing pipelines within AWS itself. For this quick demo, I am going to use Lambda, and I will try to handle a real-time streaming data use case with me, right? So let me jump in directly to my AWS console, right? What I'll try to do, I'll try to have a Lambda, which is going to process a real-time data through SNS or through SQL. Okay, so there is one Lambda with me, which is doing very simple thing, right? If you have a worked with Lambda, if you ever used AWS, you guys will be wondering that it's a very straightforward use case, but it's just to demonstrate the power of AWS as a cloud computing, right? So I have one SNS with me. So guys need not to worry what SNS is, what Lambda is. Everything will be covered in our sessions going forward in detail, right? It's just to establish the correlation of how easy enough to process data with AWS, right? So what I am trying to do is I am going to, create a message or basically publish a message. This message should be consumed and processed in real time with Lambda, which is again a service of AWS, and we will try to just display the message, right, that we are trying to create here, right? So basically everything needs to happen in real time. Let's try to see. I'll say test message. Let's create a message body. We'll say name. Name is demo, right? And we'll say date. What is the date of today? Date is 24 December 2023, right? This is one message that I am trying to put in my SNS, and I'm expecting these messages to be read and processed by my Lambda, right? So I have pushed the message, right? You can see that this message has been successfully pushed. This is the message ID, right? It ends with 517. Let's try to see if this message is getting picked and processed by the Lambda that we have created earlier, right? Let me refresh. So I'm going to view the logs of this Lambda to ensure that whatever message we have put in our SNS is basically being consumed by this Lambda or not. Okay, guys, I see one log which has been generated just now. You can see the timestamp of this log. It's 24th December, 9:14 p.m. It's India time, right? Let me try to open the logs. And in the log, I can clearly see the message which we have just pasted, right? The name demo date is this. And okay, so this is exactly what we are trying to do, right? So in simple ways, right, we have just been able to handle the real-time streaming data, which is coming in with the help of a service called AWS Lambda, right? So we just push one message here, and this message has been automatically read by this Lambda, and this message got processed, right? Now you can imagine what all things you can do. You can use this message to create a record in your database. You can use this message to create a file. You can use this message to, trigger an email. There are a bunch of different use cases which we can now build by just accessing this information. Right. Let me try to put one more message this time. I'll say test message 2. Right. We'll use this. We'll say now demo 2, and let's say demo 2. Date is this. We'll add one more field. We'll say new field, and we'll say value is random. Anything. I'm just adding random values here. Right. I'll push this message. So my message has been successfully pushed. I'll quickly go back to my logs to see whether this message has been processed or not. Right. Let me refresh. Let me refresh. Okay. It should be processed by now. Right. And you can see that the message that I have just pushed has been processed. Right. Everything is happening in real time. Right. And that's the beauty of cloud computing, or AWS is, right? So you can see how simple it is. I'm just with the help of few clicks able to process the real-time streaming data. And now I can do bunch of activity with this information, right? So same thing will be covered in our session going forward. There will be much more interesting things that we are going to learn with our data engineering session. We are going to build full scale data engineering pipelines. These pipeline will be streaming oriented. These pipelines will be batch processing and much more, right? So I'll take a quick pause here to see again if there is any question, any doubt, or any query which is coming in your mind.
Hi, Adit.
Yeah, hi.
Aditya side. I have one question. What will be the maximum size of file Lambda can handle to process?
Sorry, your
That's
voice
all.
is a little blurry.
Just give me a second. Is it better now?
Yeah, I'll try to see. I understood that Lambda and file, something like that.
Shall I repeat my question?
Yeah, yeah, please. If you can type the chat as well, that would be really good.
Uh, okay.
Meanwhile, Ash and Kumar, do you have any questions?
I can prefer Adi, can you hear me?
Yeah,
Aditya?
the question is, what will be the maximum size of file lambda can be handled in batch processing?
Yeah.
Okay. Okay. So there are various ways to answer this question, and there will be multiple answer. But the way I see this, Lambda has a ephemeral storage, and that storage can go up to 10 GB, right? Which is the temporary storage of the Lambda. And the amount of the file that Lambda can handle is totally or heavily depending upon the ephemeral storage. So if I have 10 GB of ephemeral storage, I should be able to easily handle a file of size 5 GB. But again, I can be wrong here. I need to go back and fully check and test this out because I haven't came across a scenario where I will be using or handling such large file with Lambda. For that, I have other services like Glue or EMR, but I'll check that. But the answer that comes to me is depending upon the memory and the ephemeral storage that Lambda has, because Lambda has to read the file in memory, and the in-memory capability of Lambda is not beyond 10 GBs.
You're also covering Redshift on your real-time project for data warehousing.
Uh, I heard Redshift. Is it the question that we are going to cover Redshift?
In real-time project, basically.
Uh, what I heard is, are we going to use Redshift in real-time projects? So can you elaborate what exactly this means?
So, you said you will give a demo for real-time project, which has the batch data processing and real-time processing. Okay.
Right.
Yeah. Now, actually, are you covering Redshift service also for AWS for batch or maybe streaming for data warehousing solution?
Yeah. So we do have Redshift as one of the services that we are going to talk about in our solution going forward. And for storing the data in Redshift, uh, there are various ways to store it. But for handling the real-time streaming data, it is advised to use DynamoDB as compared to Redshift because it's more of a analytical solution that is built on top of the servers.
Okay. And you're covering data models also, or creating data models like Star schema is not schema.
What I heard vaguely is data model. So yes, we do cover data models, the basic understanding of data modeling, data warehousing in our course down the line. We will talk about the various categories: Snowflake schema, then star schema, then galaxy schema, and so on. Yes, that's all will be covered.
Thank you.
Yeah. But I'll go back and check the maximum file thing that can be handled with the help of Lambda, because we generally uses Lambda for streaming or files that are smaller in size. But that's a good question. Thank you for posting.
So any other questions? Tariq and Ratna Kumar.
No, no, no. Thanks.
Ash? Ash, do you have any questions?
No, I don't have any questions.
Okay, and Ratna Kumar? Ratna Kumar, are you there? Okay, so if you don't have questions, then we can wind up for the day today. And let me call you tomorrow early morning. We can discuss about the plan, about the course and everything. Okay, thank you. Thank you, Aditya. Thanks for your time.
Thank you so much. Bye bye.